Good afternoon, Jan.
Michael, good morning for you.
How do you do, sir?
I'm doing fine. Everything is well uh, for the moment. Yeah,
We're
at
expecting
home
some
alone,
trouble.
so it's quiet. That's a very
Uh,
nice cup.
oh, yes, yes.
Debugging. It's a nice.
It's like being a detective in a crime movie where you're also the murderer.
Yeah. Were you also the murderer? Okay.
Yes. Yeah, and it's got a little bit of that CSS uh, meme going on there as
Mm,
well.
yeah. What about you?
Yeah, yeah, doing yeah, getting started on the new Pluralsight course. So I put together a really quick introduction to TypeScript. So I'm looking forward to getting that recorded, and then we'll move on to more React Native specific stuff. But yeah, I get to spend a little module talking about just the essence of TypeScript that makes it something that I love. Um,
Okay.
yeah,
So it will be a mix of TypeScript and React.
React Native specifically. Yeah,
Okay. Oh, that's interesting.
yeah.
When will it be online?
Um, probably late December. So we're targeting mid December for the release, or for
Hmm.
the um, oh, almost had a
Yeah, we had a
uh,
visit.
okay. Yeah, he was in the chat earlier this week,
Mhm.
so he just barely missed us last week. Um, but yeah, targeting delivery of the last module, December 12th, I think, is the due date there. So it'll go live after that review, which is usually pretty quick.
Mhm. Let me know when it is online.
Yeah.
I might learn something about it. And you still had the time to sleep because I saw if you're working on Pluralsight, I saw all the commits coming. I even don't have time to decipher what you program.
Yeah. Yeah, I thought it was going to be a nice quiet week, and it's like, okay, let's
Mhm.
just you know, wrap up a few things. But yeah, it turns out um, that the those last mile things, um, they kind of ramped up in a really a really intriguing way. They started out, it's like, okay, I want this to work. Oh, well, that was easy. Okay, now I want this. Oh, that was easy too. And then it got just a little bit harder, and it's like, well, that should be easy, but yeah, now I have to really think about this, and so I was just kind of sucked in.
Mhm. Yeah, I saw that because you even got to the Android part uh,
Yeah, yeah,
of the.
that's that's really the IDE switching things on me all the time. I usually try um, to uh, to exclude those changes, but sometimes yeah, I forget and they creep into a
Mhm.
commit. Um, yeah, yeah, I would like to remove those two projects from the solution. Yeah, I might actually just go ahead and do that because it'd be really easy to recreate them. There's nothing value in them right now. I just wanted to make sure that I had the project structure so that I could say, okay, here's all the core stuff, and then here are the things that are necessary to make this work on Android and on iOS.
Yeah. Mhm. So tell me about all this
Yeah,
intriguing stuff.
yeah. Well, uh, rather than just tell you, I can show you. So,
Okay.
and hopefully our friend will come
Rejoin us.
back.
Yeah.
Oh, I've been doing all of this without. Let's see.
You didn't start a stream.
I did start the stream, but nobody can see us on the stream. Uh, yeah. Let me debug this real quick. See why Discord is not showing up. Okay, so Discord is a screen. Discord. Uh, okay. There we go. Yeah, the problem was apparently the most recent Discord update changed the title, and OBS uses the title in order to identify the window.
Yeah.
So I said I can't find a window with that title. So yeah,
Mm.
hello folks. Yeah, here's the coffee mug that we were just talking about. Okay, all right. Okay, now let's see if I can go to.
But it has been a while that Discord threw us out after 50 minutes, or threw me out after 50 minutes. So the updates are useful, apparently.
Yeah, okay, there's some more fixing I need to do in order to get the... Alright, there's our pictures on the screen. Okay, and now I've got that. Okay, so yeah. Okay, and so I'm sharing on Discord. Got it on the stream. All right, now we're ready to go. Okay, so in Jinaga 02106, there are a few notable changes, and they kind of started as, you know, this is a thing that really should work, but it doesn't. You know, what's it going to take to make it work? So, big notable change is now with Jinaga Client. When you create, you can set the HTTP endpoint. I wanted to do this because I wanted to start testing Jinaga.net against the Improving You database. So, so I just set the HTTP endpoint to Jinaga, which is running Jinaga.JS on the Improving You application. So for that, I used the options pattern, which is has become really popular in ASP.NET. So I'm going to kind of live in that space, even though it is related to mutating properties, but you know, we'll ignore that. And so then, in order to kind of test this out, this is the greater half of the Improving You model, expressed as C# records. So if you've ever done any entity framework stuff, you know you've got big entities, and then migrations and all that other stuff. To an equivalent model in Jinaga fits in just a couple of two-liners.
But now that I see this whole model just in this Jupyter session, it's very compact with records.
Mm-hmm.
Just the fact type and the record, and that's it.
Yeah, that's all it takes.
Mm-hmm.
That's all it takes. And so yeah, I could even say let's grab from NuGet the Jinaga graph viz package. And then I can say using Jinaga graph viz, I want to get the visualizer. What did I call that? Renderer. No. Oh, goodness. All right. Help me out just a little bit here. Yeah. It is called renderer. Okay. Renderer dot render types, because that's all I've got so far. And so I can say, show me everything down to the course name, our course title. It should be right. Course title, yeah. All right. What are you doing? Okay, it got mixed up. Okay, let's do this. Let's do this properly. Right at the top, I'm gonna go ahead and grab both of these. Go ahead and make sure that I've got 106 just to be sure. Okay. Set up your Jinaga instance. Set up your fact types, and now render from the course title. Okay. Yeah. So so yeah, doing that, it knows all of the all those relationships. So so I can see that starting from a user, that would be the creator of the Improving You company. So initially that was me. You've got the instance of the company, and then you've got several semesters in that company. Drill down to a catalog, excuse me, which is a semester for a particular office, and then the courses that are offered at that office in that semester, and then down to the titles. So we can see, yeah, all of that is encoded within this, because we've got all those uplinks. So that's what the model ends up looking like. And so let's go ahead and start querying that model. So here I have created the user with my public key, which, I mean, this was completely random, of course, but I love, every time I look at this public key, it's like, okay, yeah, I recognize that's the right one. That's the, Kamatoku key. But I'm going to have to do something with that name. Kamatoku is just too cool. Maybe I'll publish my my white paper, my math paper, under that pseudonym. Say, who is this mysterious Kamatoku? Yeah, revolutionizing CRDTs.
It might a nice name for the successor of Jinaga.
Oh yeah.
A version that runs on, I don't know which.
On a quantum computer, yeah.
For example.
Yeah, so it exchanges facts via quantum entanglement. Yeah, even though I know that's not possible. But yeah. So yep. So now we've got the company Improving created by that particular creator, and so that is how I initially set up the application. And so now I can look for the semesters within that company, and I see that yeah, we've been running this for a while. It shows 2016 is the earliest one. There was actually a different model. I did a migration of the model, so it actually went back to 2015. But yeah, the actual JavaScript application merges those two models before it displays it. But for this, I said, okay, I'm just going to code up the new model. So I'm going back to 2016. And so now, some of the new things that I got working. Yeah, let me go ahead and create an anonymous type here. So we're going to actually have an object that has the property semester in there, and then I want to show all of the companies, all the catalogs in that semester. So kind of going back here, we've got company. We are now down to the semester level. We want to show all the catalogs. So I will call that catalogs. And so it used to be that you had to say facts.all, and this took the starting fact, which in this case was the semester, and a prior specification. So somewhere up here, I would define a specification for catalog. So I'd say, given company or given semester, match semester facts, and then get all the catalogs. But that became kind of tedious. So I made it possible to just declare all that in here. So now you can just say from catalog in semester dot and right, no. I'm thinking about entity framework and navigation properties in the opposite direction. From facts of type catalog, then where catalog dots, and it's underscore in for reasons that we won't go into. That's not the preferred way anymore. Equals semester select, and then I can do stuff like office equals catalog dot. Well, office should be in there. Oh, new. Select new. Yeah. And so that defines that type. So now, instead of having to define a completely separate specification, you can put that that link inline. Along the way, I also decided I really didn't like the word all, and because that means something in predicate calculus. It means it's like the and version of any, where any is kind of like the or over a collection. So if anything it matches this predicate, then the any predicate is true. But if all things in the collection match this predicate, then the all predicate is true. But that's not what we're doing here. We're just really producing a collection. So I went searching around for a different name. The name that I settled on was observable, which will make a little bit more sense once I show you the next feature.
Facts.collection.
Yeah, facts.collection was one of the things running through my mind. But yeah, we'll talk about the next feature, and then we'll see why observable is the one I settled on. So in the meantime, so what I've got now is for each semester, I'm getting this collection of catalogs, and so it's got the different offices in the catalog. So yeah, you can see the kind of the evolution of the company. Where's 2017, 2018? That might actually be related to a defect that I noticed. So yeah, this information is not coming back as complete information. But yeah, you can see in 2022, we had Atlanta, we had Chicago, the Cleveland and Columbus offices merged into Ohio. So all that history is kind of visible in the various catalogs that are coming back. But yeah, 2016. That's not true. We did have the Houston office in 2016. Anyway, yeah, and certainly College Station. But
perhaps there were no offerings in the Houston office.
Yeah, that. Yeah, I'll have to go back in history and see. Because we've got all that history. This is what's so amazing about this experiment. Okay, so yeah, now we're getting back all of the catalogs for each semester, and we can do that inline. So that was an improvement. That was one of those things that's like, yeah, this really should work. This is what people are going to try to do. So let's make it work. But then, I want to go one step further. And I want to say, well, people are actually going to try to do this. right? Why don't we just make that work? And so I did. So now you can just get a raw collection of catalogs by just using the link. So the distinction, the reason you would want to do this is the data type. Observable returns an iObservable collection of the projection, in this case, the anonymous type. And iObservable collection allows you to say when on added and on removed from that collection. So that comes into play when you do not a j.query but a j.watch. So so you get your j.watch, and then inside of your Lambda where you're responding to seeing a brand new semester, you say, okay, now I want to observe the addition or the removal of a catalog, and then bind that to the user interface, and then keep on nesting it inside of there. So if you don't have facts.observable, then what comes back from this link is just an iQueryable. So iQueryable doesn't have the unadded, unremoved. So yeah, that's why I renamed it to observable, is that's really the only thing that it's doing over and above what you could do without it, is making this collection observable.
Yeah. That seems like a very good name.
Yep, I think it worked out pretty good. So, yeah, so I think last week is when I first demonstrated projecting an individual field. So now we can project iQueryables. We've got the rename and using the inlining so that we can more easily create observables. And I believe that is just about everything.
That's nice. That makes it again more compact, and more logic also.
Yeah. Yeah, and you can still, if you want to, you can still take this, call this the specification. Like so. And now I'm going to split the cell so that from here I can just say specification.toString, and so now you can actually see, okay, there's the the code that you could actually just put into the replicator in order to get all this this information directly from the replicator. Yep, so do that or run it, whichever way you like.
Well, that was to because we had to string and we had to description, but it's actually the same then.
Yes. Yeah. So the reason for the difference, to descriptive string has an optional parameter of depth, and so it's used recursively, on all the different parts. So, in fact, there's a depth bug right here. You can see this is indented one more level than it should be. So, have to go back and fix that bug. But yeah, you can't overload toString to give it additional parameters and still have it be the same toString that other things are going to call. So,
okay.
So yeah, I just had toString call toDescriptor string with no parameters, and that way, if you're in the debugger and you just hover over specification, then you're going to see a nice description of it.
Mhm.
So, yeah, diving into those descriptions or into those specifications got pretty tedious. So I said, no, I'm gonna find a way to describe a specification, and then I say, hey, you know what? That's useful. I'm going to use that in the replicator, and then you know what? Hey, that should be the language that that it uses in order to produce feeds. Yeah, this whole specification language here is what kind of snowballed into, you know what? This is the right way to do query inverses. The way that I talk about it in the book is wrong, and this is the right way to compute feeds and therefore compute interests. The way that I talk about it in the book is way too complicated. Um, so yeah, now it's circled back to I need to publish this.
So after the pluralsight session, you
Yeah.
should start on a version 2 of the book.
Yeah. Yeah. The plan is where are we? Yeah. Let's turn that back off. Okay. Yeah. The plan is to after Pluralsight to work on 8 videos, 8 short YouTube videos that they will form a little tree. So it starts with just historical modeling, what how you can understand a problem using immutable facts, and then it goes into specifically the specification language and how you can use that with a distributor. And then it branches off and goes down the .NET route or the JavaScript route. And so talks about Jinaga.net and how you can write specifications using LINQ, or Jinaga.JS and how you can write specifications using template or specification functions.
Yeah.
And then branch each of those two, and then in Jinaga.js we'll talk about React or React Native, and then in Jinaga.net we'll talk about Maui and Blazor.
Okay.
So yeah, then with those 8 videos, I'll be able to say, hey, I've got a job for somebody. Post this on Upwork. I want you to write a Blazor component that does this. So watch these 4 videos. So you get the introduction, the replicator, the .NET, and the Blazor, and say, watch those 4 videos. I'll pay you to learn, and then I'll pay you to code this component.
So that these videos will actually be end-user videos. It will not be on the implementation, how it works internally.
Correct.
Okay.
Yeah, it's for the developers who are going to be using Jinaga.
Yeah.
Yep. So
yes, that's where I say you update the book, but then from from an internal.
Yeah.
But
yeah.
I'm not sure whether it's whether it's whether it will add anything to update the book. Yeah, knowledge, yes, but it will be a lot of effort, and there will be no income, I think.
Right. Yeah. No income for that, but that is still something like that is still part of the plan. Perhaps not an update to the book, but certainly some papers, hopefully published in a peer-reviewed journal. That would be fantastic. But even if they're not published in a peer-reviewed journal, I can do a Nakamoto style, just put these out on the on the internet as PDFs. Yeah, so that'll be my Kamatoku papers.
Because the book was a mix of end user and programmer, or Jinaga itself. While the videos are just the end user part.
Right. Yes.
And it might be interesting to keep them apart.
Yeah, I think so. So the Jinaga experiment is this idea of end user videos, jobs on Upwork, collect the data of how long does it take people to learn this thing and be useful in it and build a thing, and then take that data and use that in order to make
It's people.
predictions about hey, if you want to build this product, let me break it down into these components. Look at this data. It's going to take you this long, and my hope is that that number that I get at the end is going to be a small fraction of the number that you would expect if you were to just hire somebody to write this thing from scratch. So that's the end of that, the end product of that Jinaga experiment. But in the meantime, also, I want to further the study of CRDTs. So I also want to publish a few papers about the History CRDT. So a CRDT, conflict-free replicated data type, it is a small set of constraints that help you to prove that a data structure, when replicated across several different nodes in a distributed system, will reach strong eventual consistency. So eventual consistency, we all know, is that eventually everybody agrees upon the same answer. Strong eventual consistency is the additional constraint that they do that without any voting, without any further follow-up. Instead, it's just as soon as everybody's got all the information, they have the same answer. So very, very valuable thing to be able to prove. And so history is a CRDT, and that's what I'm calling the abstract data type that Jinaga uses.
Okay, so the history CDRT is actually the data type in Jinaga.
Right. Yes.
Okay.
Yes. And so that data structure and that set of operations is the history CRDT. And then with these papers, I want to further claim some additional constraints on that CRDT that are useful, but are not general CRDT constraints. So one of them is that that you can reach strong eventual consistency for a particular projection, a particular question that you're asking, using only a subset of the history, the internal data structure. So that's useful because I can write a service that looks for the integration with Azure DevOps. That's one of the projects that I want to run with the Jinaga experiment. Is here's an application you can use to take a look at all your tasks in Azure DevOps and submit pull requests and all that fun stuff. Maybe even integrate that with with Teams or Slack or whatever you're using to communicate on your team. So there's going to be a service out there that's looking for certain facts to occur, like a new pull request or a new intention for a pull request. Maybe it's a new request to push to the QA environment, something like that. Somehow some user expresses that intent. So this little service is looking for that intent and then making the API calls on Azure DevOps and then recording the response from Azure DevOps. And then that's all it does. It just runs a little Azure function, AWS Lambda, whatever. So it's working with just a subset. It only cares about that type of fact and its predecessors. It doesn't care about anything else that's related. But yet it's getting the same answers as if you were to ask the mobile device that same question. And that's a useful feature.
You mean that you only need a subset of the facts and that you don't need the complete database?
Correct, yes.
Okay.
Yep. So, for example, that is not a feature of the Git CRDT. Git is a CRDT. But with the Git CRDT, you're, even if you are projecting maybe just a folder, you still need the entire repository in order to project that folder. There's a Git operation that will that will turn one folder into a separate repository. So it'll take all the commits that relate to that folder and it'll create a new repository, but that repository won't merge with the original. So it's not a proper replica. But with history, a subset still merges with the original.
I don't really follow it with the Git example.
Yeah. So let's say that you've got a mono repo, which is a pretty popular thing these days in Git. So all of the different microservices that you're writing, they just are different folders within a single repository. So if somebody is just working on one of those microservices, they only want the source code for that one, then they have to either clone the whole repository just to work on that one, or use a Git submodule. So Git submodule will produce just that folder in a separate repository, and then Git has some extra logic in there to merge a submodule back into the main repository, but that logic is making assumptions and resolving conflicts, and it's not a true CRDT.
Mathematically, it's not always correct.
Right. Yes. Yeah.
Okay.
Just like Git merge is not a CRDT merge because mathematically it's not always correct. It requires the human to resolve conflicts. Okay, so what we were talking about was, so that feature of the History CRDT, that it can work with just a subset, is a valuable feature, and so I want to talk about that feature. I want to show that the History CRDT, with its additional constraints, it has that feature, and kind of open that up for academic research, so people can come up with other CRDTs that have that feature as well. But then, what can you prove based on having that feature? And so that is probably a paper in and of itself. It might actually be, I don't know if I need to break that down any further. But then there's another additional feature of the History CRDT, which is also very beneficial, and that is that when you express a projection, there's enough information in that expression to tell a peer what updates you need to know about in order to become consistent under that projection. So that's what we're doing with feeds. So I write this specification and send that, just the specification, to the to my peer, the replicator that I'm talking to, and then it's able to assemble some feeds that have the particular updates that you're interested in. And then in the case of the History CRDT, an update is a tuple of facts. So being able to express what subset you need just with the specification is useful, because that means that now you can construct your network of replicators, and then your client application, you just write some link, turns into a specification, and then that specification flows in one direction through the replicators, and that sets up the feeds that then flow the facts back to that client application, and just the subset that client application needs. So it kind of builds on that subset capability.
So that's actually the property that you don't need all the records, which is partially based on the bookmarks.
So the bookmarks come into the proof of why that's enough. So when you set up that feed, you need to be able to prove that that as you read from the end of the feed, and that's what the bookmarks help you to do, that that you will not miss any important information. So if the feeds were such that they would insert into the middle any new tuple, then somebody who's already read past that point will never see that. So so that's an important reason why when you give a specification to a replicator, it gives you back a collection of feeds. And so it's not just, here are all the courses that were offered in that semester. Let me give you a feed of those courses, because somebody could remove a course, and then it would no longer be in that feed. But then they could add that course back in, and it would show up back in the place where it used to be in that feed. And somebody who had already read past that point wouldn't see that course being undeleted. So so it has to, in parallel with that, give you the feed of all the deletions, because otherwise you wouldn't see those. If you'd already read past the course, now the course is in your replica, and somebody deletes it, it's removed from the feed, but you still have it in your replica. You're no longer producing the same answer as somebody else. You say, give me a list of courses. I see this one. They say, give me a list of courses. They don't. So so you have to have a feed of the courses, a feed of the deletions, and then a feed of the restores. So you have to have 3 feeds in order to make it so that you can always read from the end of those feeds and not miss any information.
Deletions and restores,
Yes.
In fact.
Yeah. And that's because when you write the specification, it shows up as a where not exists the delete, and then inside of that, where not exists the restore. So so when the replicator produces feeds, it always goes into the where not exists, and it says, oh, I need to create a new feed just for that thing. Here's another where not exists. Oh, I need to create a new feed just for that thing.
Yeah. The CRDTs were complicated.
Yeah. Yeah, it's one of those things. It's a very small set of rules, but yeah, the way those rules fit together can make some really complex structures. So yeah.
But in the beginning, when you started thinking about historical modeling, you were not aware of CRDTs.
Nope, I was not. Didn't know that I was building one.
So you invented it, and then you say, hey, they are calling it a CRDT, and I'm a special case of a general CRDT.
Yeah, that's the thing. I was a special case of it. Yeah. So yeah, I do not claim that I co-invented CRDTs. Along with Mark Shapiro and Nuno Pergusha and their collaborators. But yeah, I invented a CRDT before I realized that's what it was. And then further, reading their work, I was able to start to put some formal structure around the History CRDT, and it got better because of that. So without that, I would just be kind of, just kind of flying with just the, oh, that's funny. This doesn't behave the way that I thought it should. Let me drill down in that special case and say, oh, in this situation it should do that, and then I would just be, programming at that complicated level. But by now understanding the math, and hopefully expanding upon the math, that's why I wanted to write these papers. Then I'm programming at the level of, if I write this code, then I know that this will be true. Knowing that this will be true lets me prove this other thing. This very useful outcome. So yeah, writing this code lets me know that that tuples can be removed from a feed, but cannot be reinserted. Okay, that's that's a useful thing to know so that I can prove that that you get strong eventual consistency, based on a subset, based only on the specification.
Yeah, it's an amazing history of the CRDT, of the history CRDT.
Yeah.
CRDT with privileges.
Yeah. True.
Good.
All right.
Yeah.
So how is the SQLite going?
Yeah, I'm still struggling with it. I'm still going through your code, but I need more time for it. I had a little bit of time this week. I went through some old videos where I said, "Oh yeah, that one I forgot. That one I forgot." That's a bit of a problem with the videos. Actually, we don't have a summary of it. You have to watch the whole video to say, "Okay,
Yeah.
While the book you say, "Okay, chapter 8, go and look."
Yeah. This is no replacement for a curated walk through the topic.
Because there are so many little things which we discuss, and you retain them, but I forget them. And afterwards, I say, "How was that?" And then you have to go and search. And then watching an old video, I say, "Hey, but that I never realized." But okay, cool. I'm still struggling a little bit with the code, but we are getting there.
Yeah.
So step by step, my eyes open a little bit further. But so it will be good that you work on that Pluralsight video.
Yeah. Give you a little bit of time.
A little bit.
Yeah.
Good.
Excellent. Yeah. Actually, I was just remembering. So I was thinking about. Hey, you're understanding the SQL code, and so I wanted to make some assurances that I was not going to be touching that SQL code because I think that is, that is baked, and then that made me realize, oh yeah, I noticed a difference in the behavior Jinaga.net versus Jinaga.JS, and Jinaga.JS is correct, and that's what led me to realize Jinaga.net has a bug in it somewhere. So this actually is a perfect demonstration of that defect. So let's go back here. All right, so yeah, we looked at this this data and said, no, this isn't right. I'm missing some semesters. I'm missing some offices. So we can figure out what's happening by taking this this information here and going into Postman, and then
send it directly to the replicator.
Yeah. So let's open up my workspace for improving you, and yeah, so there's my Jinaga.read. Let's just go ahead and, this is still, actually, yeah, this is simpler than the simple example that was there. Okay. Yeah, so we've already defined the creator, Kamatoku, the company. Here's the specification, and I'm going to read from it. And so now I get back all of the information. If I just search for 2016, 2016 does have just Alice in it. Okay. 2017 is not there. Yeah, all right. So at least that's telling me that this is not a manifestation of the bug that that I noticed with a different specification, much more complicated one. But yeah, this actually is looking like this is the true
Actually,
state of the data.
This Jupiter, he was connecting to where? He was connecting to.
Yeah, it is also connecting to in preview
To
courses
this.
asherwebsites.net, so the same thing is there. The difference is when Jinaga Client does it, it uses the feeds endpoint. Oh, I changed that for some reason. That should have been feeds. There we go. Yeah, it uses the feeds endpoint, which then gives me back the collection of feeds. And then it's using the bookmark in order to walk those particular feeds and pull those into this Jinaga client. So it's got those in its in-memory store. And then it executes the specification against its in-memory facts. So it takes that same specification after it has completed walking all of those feeds, pulling them in, and says, okay, everything's up to date. Then it runs that specification and produces these results. So the bug is somewhere in there. Yeah, there's a lot more steps happening here. The reason that there's a lot more steps happening here is that that means that it is acting as a cache. So it's actually producing a replica of the facts that are necessary in order to answer that question. So it's producing that subset by walking those feeds. If it already has all the information that it needs, then when it tries to walk those feeds again, it's going to say, the replicator is just going to say, you've got everything, there's nothing new. It's going to return empty collections for each one of the feeds. So that walk ends more quickly, and then it produces the output. Yeah. Or as we discussed last week or the week before, when I add a timeout here, then we could set it to 0, and it'll say just run it against your local database. Whatever you've got cached is good enough.
Okay.
Yeah.
But so this one is running against the feeds.
Correct.
And
yes.
in Postman, we were working against the read interface.
Yes, exactly.
Okay. Yeah.
Yep. And so this is the SQL that you're emulating right now, and I have confidence that this is correct, because when I see something that has a different response, I can dig through the data and know that the .NET one is incorrect. It doesn't have all of the information that it needs. So I have confidence that the JavaScript one is correct.
Okay. So that there is no data available for 2017.
Yeah, I'm going to have to go back and see why that's the case. I wonder if... Yeah, I can come up with all sorts of stories about why 2016 has one office. It could be that as I was developing that feature, I released it in 2019, the new model, but maybe I tested it by inserting some courses into 2016. Maybe I did that thinking, yeah, nobody's looking back this far. Let me go ahead and I don't know. That was 2019 was so long ago. Oh my goodness. The world has changed since then.
Absolutely. Before nobody knew COVID, there was no inflation. There was no war. Yeah. But there was only a little bit Jinaga, and now there is a lot of Jinaga.
Yes.
So
net positive. That makes up for all those things.
Yeah. Okay.
If only.
Good. Yeah, there were 7 minutes left, but I think
I
unless you
think so.
have other things to demonstrate,
Nope.
then I go back to work and continue with work and make some time for Jinaga.
Very good. Indeed. Yeah.
Okay,
Thank you very much, Jan.
then see each other next week, Thursday, I think.
Yes. Yeah. Next week, Thursday, and then the week after that, I will be in Las Vegas. So we'll skip that one.
Okay.
When I get back in November.
You go gambling.
No, this is for the company retreat, and usually I don't do any gambling. Mathematician, it's very hard to convince myself that that's a fun thing to do. But
Unless you want to lose. Unless you want to lose.
yeah, exactly. But actually, one of my friends says, told me, hey, I've never actually been to Vegas. I've never done any gambling. I don't know if this is something I would enjoy or not. And I said, I will go gambling with you, just to have you, help you have that experience. And then
Stop him in time.
yeah,
Mathematics, you should stop now.
yeah. Rather than do that, actually, we've had the blockchain talk because he's he's an investor in Bitcoin. So actually, he is a gambler, but he just doesn't think of it that way. But yeah, so you can't convince him not to spend his money on Bitcoin with logic. So I'm not gonna convince him not to play blackjack. We'll just go and play some blackjack.
Look, as long as life is fun, why not?
Yeah.
Okay, Michael. I'll see you next week, Thursday.
Yes, indeed. See you then.
Bye-bye.
Bye.